I hope you're all doing okay. The last big topic we're going to do is the open economy. So there is a lot of trade between countries. Here you can see exports and imports, and countries actually differ more in the level of both exports and imports than they do in the gap between exports and imports. So some countries do a lot more trade with the rest of the world, and big countries tend to do less trade with the rest of the world just because more is happening within a big economy, and then smaller economies tend to trade more. But there are other forces that also affect how much countries trade. But you can see for South Korea, it's almost half of GDP that's imports, and half of GDP that's exports. The gap is much smaller, but it's about half of GDP is imports and half is exports. The U.S., it's in the teens. In an open economy, spending doesn't have to equal output. Saving doesn't have to equal investment. So there are changes that happen. Let's look a little bit at the accounting. Consumption is consumption of domestically produced goods and consumption of foreign produced goods. Same for investment, same for government purchases. And exports is foreign spending on domestic goods. Imports is U.S. spending, or the domestic country spending on foreign goods. And net exports is the difference. Net exports simply means exports minus imports. And there's going to be a lot of different names for net exports. Sometimes it's called the trade balance, or trade surplus. You could also say if it's positive, it's a trade surplus. If net exports is negative, that's a trade deficit, as it's sometimes called. Okay, so GDP is equal to expenditure on domestically produced goods and services. That is domestically produced consumption, domestically produced investment, domestically produced government purchases, plus exports. And that we can write the domestically produced consumption as total consumption minus foreign produced consumption, same for investment, same for government purchases. And when we do that, you can see that you're really adding exports and then subtracting imports. So as we talked about early on in the semester, we're subtracting imports because we never should have included them in the first place as part of gross domestic product. But when we're doing C plus I plus G, we are including imports, so we have to take them back out. So C plus I plus G plus NX equals Y is the open economy version of that familiar equation. We've said C plus I plus G equals Y for a while. Now we've got to add net exports because it's an open economy that we're thinking about. There we go. Now, let's rearrange that equation, and then we see that net exports is equal to output minus domestic spending. So whatever is produced and is not consumed, invested, or purchased by the government, then is left over for net exports. That output has to go somewhere, and so we have this relationship. Net exports is exports minus imports. It's Y minus the quantity C plus I plus G. Trade surplus means output is greater than spending and exports are greater than imports. The trade deficit means spending is greater than output and imports are greater than exports. And the trade deficit is just minus NX. Now let's talk about this concept of net capital outflow. Net capital outflow is saving minus investment. If we save funds and we don't invest them, then they're going to have to go to be invested in other countries. This I, remember, is investment that's in things that are going to be, factories, machines that are going to be used in the United States. So saving minus investment is the net outflow of loanable funds. It's also equal to the net purchases of foreign assets. By net, I mean the country's purchases of foreign assets minus foreign purchases of domestic assets. When saving is greater than investment, a country is a net lender in terms of at least the new flows. When saving is less than investment, a country is a net borrower. Now, there's a link between trade and capital flows, and we can see it by looking at the national income identities. So we know that net exports is output minus quantity C plus I plus G. That implies that, just rearranging a little bit, that net exports is Y minus C minus G minus I. But guess what? Y minus C minus G is output that isn't consumed or purchased by the government is saving. Therefore, drum roll, net exports is equal to saving minus investment. So the trade balance equals the net capital outflow. Super important. We're going to be talking a lot about this and using it a lot. So net exports is equal to the net capital outflow. And as we'll talk about later on, it's actually the net capital outflow that causally is determining the trade balance, and to a much greater extent than the other way around. And so you end up having to think about where people want to put their loanable funds, where people want to put the money they've saved. Do they want to put it into US stocks and bonds? Do they want to put it in foreign stocks and bonds? How people choose to do their portfolios is going to affect the net capital outflow, which in turn affects the trade balance. But more on that later. At the moment, you can see that as an accounting matter, the trade balance equals net capital outflow. This is ironclad because it's a matter of accounting. Okay, a country with a trade deficit is going to be a net borrower. A country with a trade surplus is going to be a net lender in terms of the new flows. Okay, so now we've got a clicker question. And, if you want to go back and listen to the last minute or two of the video before trying to do this clicker question, that's fine. Here I'm gonna turn on my video in case it's slightly entertaining to have a little Miles head there out in outer space. I don't expect it to be terribly entertaining, but maybe compared to these slides, it slightly adds. So think of the equation on the previous slide. Which of these does it imply? And I'll just put these down. I won't try to read them out loud. And stop the video and make your choice. Okay, so which one is true? The one that's actually true here is D. Remember, we had saving minus investment equals net exports. Capital outflow equals net exports. If we just add investment to both sides, then we find that saving is equal to I plus NX. And when we get to the graphs, which will be a different recorded lecture, S equals I plus NX is going to be a key relationship that we use, and we'll writing it out that way will be helpful. I'll leave it to you why each of these other equations is wrong, except to point out that C, S equals I, is true in a closed economy, not true in an open economy. Okay, so let's take a look at this identity, this accounting identity that says that saving minus investment equals the net capital outflow. So it's a little tricky because you've got to see the trade balance on the right-hand side. So trade balance is if the brown line is below here, maybe that's tan. No, I think that's brown. If it's below this level, you have a trade deficit. A trade deficit is what you expect if investment is above saving. And you can see up here that for quite some time, since 1982 or so, we've always had investment above saving. And since 1982, we've always had a trade deficit. It's not like we had, given that this is the zero line for the trade deficit, it's not like we've had a huge trade surplus before that, but we've had a pretty big trade deficit since about 1982. Oh, excuse me. Oh. All right. Okay, so the US, partly the US has a big economy, but it is a very big debtor nation. Now, I emphasized before that identity was about the new flows. It's the fact that we've had investment above saving for a long, long time, or saving below investment. Those are obviously the same thing. That for a long, long time, that the United States owes a lot of money to other countries. Now, some people say, oh, that's because U.S. investment is high. Other people say, oh, that's because U.S. saving is low. But at any rate, it is a big trade deficit and a lot of capital inflow to the U.S. Folks sending funds to us. I mean, it is good that the U.S. has as much as an investment as it is, but if you to the extent you think a trade deficit is a bad thing, which many people do, I think the remedy is to increase saving, not to try to reduce investment. Okay, as of, well, this is way back in 2014, but even back in 2014, US residents owned 24.7 trillion of foreign assets. Foreigners owned 31.6 trillion worth of US assets. The net indebtedness back then was 6.9 trillion. That's almost a third of a year's worth of GDP. Okay, now, here's another relationship that is not an identity, but is an important economic relationship that you should pay attention to. The US budget deficit, when we get to the theory, I'm going to argue has an effect on capital flows and therefore on net exports. So when we have a big federal budget deficit, some of the money that the government is borrowing, because that's what it has to do when it has a deficit, gets borrowed from abroad. To the extent money gets borrowed from abroad, that's a capital inflow, which tends to cause a trade deficit. So let's look at how this graph works. So net exports are on the net exports are on the right scale. The federal budget deficit is on the left scale. A higher deficit should reduce net exports. So these should be, according to the theory, they should be going opposite one another, and they often do. Not always, but they often do. Okay. Now let's talk for a bit about the nominal exchange rate. and contrast it to the real exchange rate. So I'll use a little e for the nominal exchange rate. That's the relative price of domestic currency in terms of foreign currency. That is, for example, yen per dollar. So notice Mankiw is going to be talking about how much it costs to get a dollar. You could talk about how much it costs to get yen or euros, but he's going to say if the US is the domestic country, let's talk about how much it costs to buy a US dollar with some other currency. Okay, here are some examples. Back in 2015, and a lot of these are not too dissimilar now. It costs 0.85 euros to get a dollar. It costs 12,500 rupiahs to get Indonesian rupiahs to get a dollar. Cost 118 yen, 14.6 pesos, 65 rubles, 11.5 South African rand, 0.66 pounds. So they actually, I think they call them cents in the UK. So 66 UK cents for a US dollar. So with the little e as the nominal exchange rate, I'm going to use a little Greek epsilon to mean the real exchange rate, the relative price of domestic goods in terms of foreign goods. So a high value of epsilon is going to mean that US goods look expensive compared to other goods. And so an example would be Japanese Big Macs per US Big Mac. If it cost you 10 Big Macs in Japan to get a US Big Mac, that would be a very expensive US Big Mac. US goods would be looking very expensive. That's more extreme than what really happens. Okay, so these are, you have to look very, very carefully to try to understand these identities, but here's what we need to do. So what's the real exchange rate? We take the nominal exchange rate, then multiply by the price in the US, that's the P, and then the price in other countries is P star. So we take yen per dollars, that's this E. We take dollars per unit of US goods, that's the P. Then divide by yen per unit of Japanese goods, that's the P star. And if you look carefully, the yen will cancel, the dollars will cancel, because per dollars means it's yen, number of yen over number of dollars. And you're just going to get US, then you're just going to get Japanese goods per US good. Okay, so you've got, or another way to think about it is yen per unit of US goods over yen per unit of Japanese goods. So if it, once you translate dollars into yen, if it costs an awful lot of yen to get the US goods compared to the yen it costs to get the Japanese goods, US goods are looking expensive. Okay, so again, yen per unit of US goods divided by yen per unit of Japanese goods tells you how much you could buy of Japanese goods per unit of US goods. Okay, here's our example. Big Macs, suppose they cost 200 yen in Japan. None of these numbers are super realistic. This is just an example. Suppose a Big Mac costs $2.50 and that the nominal exchange rate is 120 yen per dollar. How do we calculate the real exchange rate? Well, we say $2.50 converted into yen is equal to, I've got to do the multiplication here, but I think that's 300 yen. So it's like once, if you had a Japanese tourist trying to buy a Big Mac in the US, they would convert that $2.50 into yen and say, oh, that's 300 yen worth. And it's 300 yen here. Back in Tokyo, it was 200 yen. So it's 1.5 times as expensive in the US Sounds a little bit expensive. Okay. And of course, that's the same as saying, wow, I could have bought 1.5 Big Macs in Tokyo for what it's costing me to buy 1 Big Mac here. Okay. So we can think of the real exchange rate, epsilon, as the relative price of a basket of domestic goods in terms of a basket of foreign goods. We don't really use a basket of just Big Macs. We have a lot of other things. Okay. But you know, literally, a good image to make that clear is to realize that basket could be what's in a shopping cart. You imagine the same shopping cart full of stuff, buying that in Tokyo, buying that in Boulder. How much would it cost once you convert to a common currency? Okay, so as I've emphasized, a high real exchange rate means things look expensive in the US. So therefore, exports fall and imports rise. If US goods look expensive, people aren't going to want to buy very many. People in other countries aren't going to want to buy many. That makes exports fall. The other thing I haven't emphasized as much is if the exchange rate is high, then we get a lot of yen for every dollar compared to how much things cost in Japan. And so things look cheap to Americans. And so if foreign goods look cheap to Americans or folks in the US, then imports will rise. So obviously, if exports fall and imports rise, net exports fall. And let's take a look at this in the real world. On the right-hand side, we've got a measure of the real exchange rate. On the left-hand side, we have net exports. And indeed, you can see these go opposite. So we had okay, so here's epsilon is in red. So the US dollar, it's called getting strong. That doesn't mean it's a good thing, but it's called the dollar appreciating or getting strong. When the dollar appreciated or got strong in the 80s, US net exports went down. And if you think that a trade deficit is a bad thing, that shows you one reason why you shouldn't assume too quickly that the dollar being strong is a good thing. It might be a good thing, might be a bad thing. I'll put up a link to a blog post that talks about the different possibilities there. And but at any rate, dollar got strong, net exports went down. Another time the dollar got strong or expensive, if you will, was in the early 2000s, and the trade deficit got worse. The net exports went down. That's saying the same thing. Trade deficit is just minus net exports. So you can see these go opposite one another. So that theory works pretty well. Let's make it into a graph. The net exports function reflects this inverse relationship between net exports and epsilon, and it's a downward sloping curve. The more expensive US goods are to other people in the rest of the world, the less, and the cheaper foreign goods look to people in the US, that's a high epsilon, the less are net exports. And on the other hand, if the US dollar is cheap, the dollar is weak, then we have high net exports. And again, there's nothing necessarily wrong with the weak dollar. Weak and strong are traditional ways of describing this, but in this context, weak is not necessarily good, strong, weak is not necessarily bad, strong is not necessarily good. It just means a strong dollar just means high epsilon, weak dollar means low epsilon. But if we have a low price of the dollar, if the dollar is weak, then foreign goods look expensive, so we don't import much. And to the rest of the world, US goods look cheap. And so we sell a lot, so net exports are high. So this is one of the key graphs we need. Now, notice something unusual here. Usually we're graphing the quantity demanded as going from 0 to positive numbers. But with net exports, because it's exports minus imports, it can go negative. So unusually, this is a demand curve that can go into the negative region. Okay, when it's low, U.S. goods are relatively inexpensive, so U.S. net exports will be high. At a high enough value of epsilon, U.S. goods become so expensive that we export less than we import. And of course, that misses the other side of the story of how things look to folks in the U.S. Here, things abroad look cheap, so we want to import a lot. Back a minute ago, when we had low epsilon, things abroad look expensive, so we import less. Okay, now determinants of the nominal exchange rate. As usual, we really want to think about real things first, and then at least in a long run model, and then the nominal just we kind of figure out at the end. So let's start with the expression for the real exchange rate. The real exchange rate epsilon, that is how strong or weak the dollar is in real terms, or how strong the dollar is in real terms, is nominal exchange rate times P over P star. Let's solve for the nominal exchange rate. We see that the nominal exchange rate, by definition, actually, is equal to the real exchange rate, which is determined by long-run forces, times the prices abroad over the prices in the US. So if we think of number of yen per dollar, that's going to depend on the real exchange rate times how expensive things are in yen, what the prices are in terms of yen in Tokyo, divided by what the prices in dollars are for things in the US. So we can do this, take logs and take the change and get percent changes like usual. The percent change in the nominal exchange rate is equal to the percent change in the real exchange rate, which is determined by long-run forces, plus the percent change in the foreign price level minus the percent change in the domestic price level. And I should point to those: percent change in foreign price level minus percent change in domestic price level. So if we do that, if we do those changes over 1 year of time, then the growth rate of the nominal exchange rate equals the growth rate of the real exchange rate plus inflation in the foreign country minus inflation in the US. So for a given value of epsilon, the growth rate of the nominal exchange rate equals the difference between foreign and domestic exchange rates. Okay, so I'm going to give you an example that is very vivid to me because I spent 2 years in Japan between 1979 to 1981. Suppose that in real terms, the dollar strengthened 1% per year vis-a-vis the yen. Japanese inflation is minus 1%, and US inflation is 2% per year. What is the yen per dollar growth? That is the growth in the nominal exchange rate. Okay, I'll give you some answer options. Stop the video and answer before you go on. Okay, so let's think of our formula. We know that the nominal exchange rate is affected by the real exchange rate. So that's 1% per year we add in. But then to the extent that Japanese inflation is higher than the US inflation, we'll get a higher change in a higher rate of growth in the exchange rate. However, Japanese inflation wasn't higher, it was lower. So if we say it's 3% lower, as in this example, then we get 1% per year from the real exchange rate minus 3%, and that gets us to minus 2% per year. Okay, and minus 2% per year for 35 years can cut the nominal exchange rate in half. And that's kind of what happened. So when I was in Japan in 79 to 81, exchange rate was like 240 or 220 yen to 240 yen to the dollar, or 220 yen to the dollar, or maybe 200 yen to the dollar. But now it's more like 110 to the dollar. So a Japanese yen is a little aluminum coin that can float on water. And back then it was worth more like a half a penny. Now it's worth as much as a penny, or almost as much as a penny. Okay, let's look at that more generally. We've got on the horizontal axis the inflation differential, how much higher inflation is in the foreign country than in the US. And on the vertical axis, we have how much, what's the change in the nominal exchange rate. And as you can see, countries that have higher inflation than the US have their nominal exchange rate going up faster. Countries that have lower inflation than the US tend to have their nominal exchange rates go down relative to the US. Okay, purchasing power parity is a concept that's important in just judging the real exchange rate. So one definition of purchasing power parity is way too strong. That's like saying, oh, the real exchange rate should always be one. This notion says that goods must sell at the same currency adjusted price in all countries, and then that the nominal exchange rate adjusts to equalize the cost of a basket of goods across countries. This is the law of one price. If there's a different price, if it's cheaper one place than another, people should just go buy it there. And taken literally, that's epsilon equals 1. And the net exports curve being flat at epsilon equals 1. Now that is too extreme. That's not what really happens. But suppose it were, then the nominal exchange rate would be equal to simply the price level abroad in nominal terms divided by the nominal prices in the US. Okay. So you've got, okay. If that were true, the nominal exchange rate between two countries would just be the ratio of the country's price levels. It doesn't hold in the real world because international arbitrage is not easily possible. It's a good question why it's as hard as it is. If not too many years ago, I was in Tokyo. I went into some music shops and looked at the price of CDs, converted them to US dollars, and I thought, these CDs are really, really expensive. Why isn't somebody in Japan importing CDs that are much less expensive elsewhere? And I don't know the answer. Maybe it's regulations, trade barriers. Maybe it's the cost of making translating descriptions of the CDs into Japanese. I don't know. That doesn't seem big enough to me, but it might be a partial factor. But anyway, for some reason, you don't have perfect arbitrage. Now, some goods, that's easier to see why. I mean, it's not like barbers could be really cheap in Indonesia, but I'm not going to fly to Jakarta every time I need a haircut. Even with manufactured goods, you have some transportation costs. A big thing also is different countries' goods are not perfect substitutes. Things are slightly different in other countries, and especially with food, people get used to very particular things. Still, purchasing power parity is a useful way of judging the real exchange rate. Nominal exchange rates tend towards purchasing power parity, or another way to say that is there's some tendency for epsilon to go to 1. Even more importantly, epsilon doesn't stray that far from 1. Typically, The real exchange rate is between about 0.7 to 1.3. That is, the real exchange rate seldom drifts more than about 30% away from purchasing power parity. And that's the end. And thanks for listening, and stay safe. And there'll be more videos coming soon.